Which equation represents the graph of a line parallel to the line at the right? Well, guys, in order to figure out if something's parallel, what do we need to know? What's the one thing that we need to know? The slope. No, this is today's, 5.7. Okay, what's the slope of this graph? Giancarlo? Good, -1/2. How'd you figure that out?
Because it went down by 1, and then it went
Good. Let's just pick 2 points. Giancarlo says it goes down by 1, so that's -1. That's our rise, and then it goes to the right 2, so that's +2. Our slope is rise over run. Therefore, it's the -1 over the +2, so -1/2. If 2 lines are going to be parallel, what's true about their slopes? They have to be the same. So we need to look for a slope that's -1/2, right? Which answer's choice has a slope that's -1/2? D is the only one, so D is our answer. Go ahead and bubble in D. Questions on this one? On number 38. Okay, what is the solution of 5x minus 1 plus -2x plus 7 equals 9? Whoa, intimidating, but not really, guys. Once we write this out, it's actually a lot easier than it seems. First things first, let's get rid of the parentheses. Remember, PEMDAS? Inside the parentheses, can we solve what's inside the parentheses? Can we add 5x minus 1? No. Can we add -2x and 7? Why not? They're not like terms. Very good. Okay? One has an x and the other one does not. So what we're going to do is just get rid of those parentheses. So let's rewrite this as just 5x minus 1 plus this. There's like an imaginary one that gets distributed, but since it's positive, it just leaves it the same. So plus -2x plus 7 equals 9. Now on the left side, can we combine anything? What? Good, the x's. So the 5x and the -2x. What else can we combine? The 7 and minus 1. What do we get when we do 5x minus 2x? 3x. Oops, I'm writing in highlighter. 3x. What about 7 minus 1? Just 6 equals 9. Ooh, now this looks familiar. How do we solve this, peeps? Go ahead, Alan. And then what? There we go. We just divide. By what? Trace. So we get x equals 1. What's our answer? Yeah, but which letter? G. Guys, these warm-ups, I'm pulling them from a special part of the book. It's supposed to be very similar to like stuff you'd see on like SAT, PSAT, those standardized test stuff. So these are really good questions to focus on because these are the questions that will matter like when you guys take the SAT for real when you're juniors, okay? And not necessarily like these questions, but these kinds of questions, right? So, You might actually see like a question like this on the SAT. All right, guys, moving on. Linear functions, scatter plots, and trend lines. This lesson, okay, is very conceptual, not very mathy, okay? So we're gonna go over what that means, but basically it's somewhat of some definitions and less math. So we're gonna have less like math, like number crunching and all that stuff. We're gonna have more definitions, more ideas behind stuff, okay? And we're gonna learn about scatter plots and trend lines. Let's write our names and let's get started. All right, our objectives in this lesson is to write an equation of a trend line and a line of best fit, and to use a trend line and a line of best fit to make predictions. To make predictions. All right, and can anyone tell me, take a look at the graph on the left, the green one. What's like going on there? Tessa?
The dots are like scattered.
They're kind of scattered, right? But do you notice a trend? And the ones on the left? Just in general. Like, are they going a certain direction?
Oh yeah, it's like
They're kind of going down, right? Like, as we move from left to right, they're kind of going in this direction. Do you guys see that? Like, there's not like dots over here or over here. It's generally going in a certain direction. What about the ones on the right?
they're like going somewhere.
Yeah, they're kind of going up, right? You can kind of draw a line that's kind of in the upwards direction, and they all kind of follow along that. Now, I would say the ones in blue are easier to see, like, they're more correlated, right, than the ones in green. The ones in green are kind of more scattered, like Tessa said, okay? Both of these are examples of scatter plots, okay? And with scatter plots, what we're going to be able to do is draw a line through them and be able to make predictions about future points. All right? Okay, moving on. Slide, guys. Those are examples of scatter plots, okay? Even though one looks way more scattered than the other one, they're both. Slide. What kind of relationship is the green graph? Tessa?
It's a negative relationship.
Good, negative correlation. Let's write that in there, negative correlation. And what about the blue one? Positive correlation. Okay, as x increases in the blue one, so does y. And as x increases in the green one, y goes down. Okay? And we're going to go over, one of these is a strong correlation and one of them is a weak correlation. And we'll go over that later as well. Okay? Our essential understanding, you can determine whether two sets of numerical data are related by graphing them as ordered pairs. If the two sets of data are related, you may be able to use a line or estimate or predict values. Make sure you get this definition in there. A scatter plot is a graph that relates two different sets of data by displaying them as ordered pairs. Most scatter plots are in the first quadrant of the coordinate plane because the data are usually positive numbers. Okay? So now sometimes we draw our coordinate planes like this. It's just saying that a lot of them you're just going to see the positive axes for both of those. Kind of like that. And those two examples on our examples of scatter plots. first. All right, guys, what we call a positive correlation. When y tends to increase as x increase, the two sets of data have a positive correlation. Also underneath that, go ahead and write positive relationship, because we'll label it either way. When y tends to decrease as x increases, the two sets of data have a negative correlation or negative relationship. And when x and y are not related, the two sets of data have no correlation or no relationship. So guys, for these graphs, look at the first one. See how if we were to draw a line through those points, a line of best fit, see how it's going up? It's increasing, our slope is positive, okay? That would be a positive correlation. If our slope is going down, like the second one, do you see how a line going through them would go in that direction? That's a negative correlation, okay? As x increases, y decreases. And then in the last one, there is no line that we could draw that would be really even close. Those points are all over the place, right? So there's not really a line we could draw at all. So they have no correlation or no relationship. Okay. I want you guys to go back. All right. Problem number 1, making a scatter plot and describing its correlation. The table shows the altitude of an airplane and the temperature outside the plane. So you're welcome. I already plotted it for you. It's down here. Okay, I gave you guys the plot. But you guys are going to be asked on your homework. You're going to be given a table and you have to plot them. So you're going to plot each and every point. Okay, and it says, what type of relationship does the scatter plot show? What do we think? Is this positive or negative? Ashton?
Negative.
Good. This is a negative relationship. Why? Good. All the points are going down as we move from left to right. So if we were to draw a line through all these, it would be in this direction, correct? So it's got a negative correlation. As our altitude increases, what happens to the temperature? Increases? Decreases. Okay? Remember, as one goes up, the other one goes down. That's a negative correlation. If they both go up together and they both go down together, then that's a positive correlation. Questions so far on scatter plots? All right. Serena, did you have a question?
Oh yeah, but it was on like the homework.
I'm sorry. Can we go back at the end?
Yeah, it's fine.
Okay. All right, let's make a scatter plot of the data in the table below. And what type of relationship does the scatter plot show? Okay, so gasoline purchases. Guys, we've got a coordinate grid over here. Let's make our two axes. None of our values are negative, so let's just keep it in quadrant 1, or our positive axis. What's the x-axis going to be? Dollars. Dollars spent. And my y-axis? Gallons bought. All right, what's a good interval to go by for the dollar spent axis? We've got our highest number is 13, our lowest number is 4. I guess we could just go by like ones, right? Carlos?
Yeah, I was gonna say maybe we could go up to like 20 or something.
Yeah, we could just go by ones and let's go up to 20. That's a good idea. Okay, so let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Let's stop at 15 because nothing's higher than 13. Okay? And then in gallons bought, I would recommend, let's go by like 0.1. No, let's go by 0.2. So each interval will be 0.2. So 0.2, 0.4, 0.6, 0.8, 1.0, 1.2, 1.4, 1.6, 1.8, 2.0, 2.2, 2.4, 2.6, 2.8, and 3.0. Do you have anything higher than 3.0? 3.3. So let's go 3.2 and 3.4. 3.2, 3.4. All right, guys, and now we're just going to plot each of these points, okay? So, dollar spent for $10. How many gallons were bought? 2.5. So let's find 2.5. So at $10 spent, 2.5 is right between 2.4 and 2.6. So you should have a point right here, right in the middle. Okay? Next, let's do 11 and 2.8. So at 11, 2.8, that's right here. Next one, we've got 9 and 2.3. So let's go over to 9. 2.3 is between 2.2 and 2.4, right here. Next one, we've got 10 and 2.6. So 10 and 2.6. It's another point right on top of the other one. We've got 13 and 3.3. So 13 and 3.3. We've got 5 and 1.3. So let's go over to 5 and go up to 1.3. That's going to be between 1.2 and 1.4. And then 8 and 2.2. 8 and 2.2. And our last one is 4 and 1.1. So let's find 4 in dollars spent and go up to 1.1. That'll be between 1.0 and 1.2. What type of relationship is this? Why? Those of you that said positive correlation, awesome, okay? As the dollar spent increases, the gallons bought also increases, okay? As dollars spent increases, gallons but increases as well. And that makes sense, right? Because if you're spending more money, you should be getting more gallons, right? There should be a positive correlation there. When two sets of data have a positive or negative correlation, you can use a trend line to show the correlation more clearly. Trend line is a line on a scatter plot drawn near the points that shows a correlation. You can use a trend line to estimate a value between two known points or to predict a value outside the range of known data points. Interpolation is estimating a value between two known values, and extrapolation is predicting a value outside the range of known values, okay? So interpolation is estimating a value between known values. Extrapolation is predicting a value outside the range of known values. Again, guys, I said this before. This is a conceptual lesson. A lot of vocab here, okay? Interpolation, interpreting a value in between known values, and extrapolation is predicting a value outside that range of known values. So how we're going to remember this. Take a look at our graph on our right, or over here. If we were to predict a point right here, this would be interpolation. If we were to predict a point out here, this would be extrapolation. So interpolation is between the points, extrapolation is outside. Yeah, Victoria? Mm-hmm. Guys, we're getting close. We're getting close. We are getting close. Writing an equation of a trend line. Make a scatter plot of the data at the right. What is the approximate weight of a 7-month-old panda? Okay, let's go ahead and again do our X and Y axes. Boom, boom. My x-axis will be the age, and my y-axis will be the weight. My age goes from 1 to 12, so let's just go 1, 2, 4, 6, 8, 10, 12, and my y-axis goes from 2.5 to 54.9. Let's go by fives. So here's 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55. Okay, and at the age of 1 month old, they are 2.5 pounds. So at 1, we're going to go right here. This is 2.5. At the age of 2 months, they are 7.6. So just above 5, between 5 and 10. There we go. At 3 months old, they are at 12.5. 12.5 is above 10, but less than 15. Right here. At 4, they are 17.1. At 4, they are 17.1. That's going to be right here, above 15. And then at 6, they are 24.3. So just below 25. At 6, they are just below 25. At 8, they are 37.9. At 8, they are 37.9. It's going to be between 35 and 40, right around here. And then at 10, they're at 49.2. That's just below 50. And at 12, they are just below 55. Almost, like literally just below 55. 12, just below 55. Okay. Let's draw, to our best abilities, a line through all these points. So start at 0, 0, and draw your best line going through as many points as possible, okay? So that way the distance between the line and any of the points is very, very small. You don't want the distance between the line and any of the points to be too large, okay? You want it to go through as best as possible, okay? And it wants to know, at 7 months, what will be the weight. So what we're going to do is we're going to put a 7 here, and we're going to go from 7, we're going to go up to our graph. What should be the weight at 7 months? Well, what two numbers is it between on the y-axis? 30 and 35. So let's just say it's like 32. And what units were we using? Pounds. So at 7 months, approximately 32 pounds. And guys, was this interpolation or extrapolation? Why? Good. It's in between all of our points, right? If we were to say, what's the weight going to be at 20 months, that would be extrapolation, okay? Because 20 months is like out here, 14. If we were to say at 20 months, what's the, we would have to go all the way up here. That's outside of our data, right? Outside of the points that were given. 7 is between 6 and 8, and we were given 6 and 8, right? 7 is between some of our points. So 7 we can predict, and it's interpolation. Extrapolation would be like if we were to find the weight at 20 months. Questions? Is this a positive or a negative correlation? Positive, good. Okay. I know we'll finish this up tomorrow. I know it's hard. Okay. This is where we're going to